by the end of this video, we would like to be able to say that I can write verbal expressions from algebraic equations or algebraic expressions, and also vice versa. Before we actually start working on some examples, though, we want to make sure we understand what a few terms are. I mentioned these terms in a few other videos, specifically the variables and also terms, so that's going to be a little bit more of a review than anything else. But an algebraic expression, this is basically it's not an equation with a equals. It's an object that does not have an equals to sign. So we can have additions, we can have subtractions, we can have multiplications, we can have divisions. Main thing is they are separated by addition or subtraction. So we could have like 4x plus 5. That is an expression. There's no equals to. Notice we have a multiplication with the x, and it's just added to another value. Another expression could be 5x minus by 7. We could also have 3x squared minus by 2 plus 5x. We can have as many additions, subtractions we need, any multiplication, divisions we need. They just have to be separated by additions or subtractions. We could even have an expression be just 5x. That's an expression. You don't have to have addition and subtraction. Main thing is you have numbers, you have variables. They can be mixed together to create an expression. And expressions are made to be able to create equations. Variables. Variables, these are your letters, like we talked about in another video, x, y, z. We like to use x quite often. We can use a. It just depends on the context. Depending on the context, like time, we might use t, or if we're working in hours, we might use h. A term is different parts of the expression. So in this example up here, this 4x plus 5, the terms of that are 4x and also 5. Okay, these are the things that are separated by the additions and subtractions. They can have multiplications as an individual term. We could also have, if we are looking at this one over here, this 3x squared minus by 2 plus 5x. The terms of that is 3x squared minus by 3x squared. We have negative 2, and we have 5x. Those are terms. They are part of the expression, but they are considered to be terms. Factors. We have factors. Factors are basically saying that this is a multiple of an object. So like if we have 4x, 4 is a factor of x. This is a product of it. Okay, we have 4 times this other number. So the number in front of the variable represents our factors. And product is another word for multiplication. Let me actually spell it out. It is the result of a multiplication. Okay, so product is the result of a multiplication. Power, let me give you guys an example of this. Let's say we have a number raised to a power, let's call it 2. Okay, so I'll call it the second power. The power is our exponent. Okay, the exponent of this is the 2. The base of this, the base of the power is the x. Okay, base is the bottom of the exponent. The bottom of the power. The exponent is the one that is up top. So if we have, let's say, y to the 7th, the base is y. The exponent is 7. That is what powers mean. We are raising it to some sort of degree, where the degree is the exponent and the base is a number that is being multiplied several times. Let's list off a few words that are that represent maybe addition, subtraction, multiplication, and also division. If we want to know some words like this, there is a helpful handout on the website that gives you the keywords. Keywords for addition. We could say that addition is the same thing as saying the sum. Remember, the sum is the result of an addition problem. We have plus. We could use plus as another word for addition. We could use increased. We could use more than. We can use total of. So these are all words that mean to add, to put two things together. Subtraction, some of the words that you guys may have seen before or heard before. We have the difference. We have minus. We have decreased by. We have less than. And we have take away. So those are words that mean to subtract. Difference is, of course, the result of a subtraction in an expression. Multiplication. Some words that mean to multiply. We have the product. We have times. We have twice. By the way, twice is 2 times something else. We have a triple, which is 3 times something else. We have half, which is half of a number, so 1 over 2 times x, or we could use 0.5 times x. Then for division, some of the key words that we have are quotient, divide by, or divided by. You have ratio. Remember, ratio is another word that means division, or ratio of. Then we have per. Per is another word that is meaning for division. Now, since we have that, some key words, let's go ahead and look at some examples. We are going to write each of these as a verbal expression for each algebraic expression. So we're going to take these and write it in words. The first one, we have 2x plus 1 over 2. Well, this is just going to be the same thing as saying twice. Let's just use x. Twice x, we could say twice some number. Twice x added, we can use added, to, we can say 1 half. That would be one way of writing it out in words. For b, we have 12 times, or 12x cubed minus by 7x squared. Okay, well, let's actually write that a little bit nicer. We can say, okay, well, we have 12 times x cubed subtracted by we can say 7 times x squared. That's one way of writing it. You could also use other words. You could say the product of 12 and x to the third power subtracted by 7, or subtracted by the product of 7 times x squared. We could do it that way. Or we could say 7 times x to the power of 2. There's different words of saying the same thing. So just because I word it one way does not mean that that's the only way of wording it. It's being able to use the keywords that we had up here and be able to write it in these contexts. Part C. We have 3y, and that's a division of z and an addition of plus 7. So let's figure out how we're going to write this. let's say that this is the quotient of, because quotient is the result of a division. So we are going to write the quotient of, let's say 3 times y and z plus 7. That's one way of writing it. This is not the only way of writing it. You could use different words to mean the same thing. But this is just one way of writing it. For D, this one's interesting. We have a lot going on. Let's first say that we have 5 times b to the 9th power subtracted by the product, because we have multiplication, the product of 3 and 2 plus b. And that would be one way of writing it. It's not the only way of writing it. You can use the similar words to come up with the same results. So that is an example of writing a verbal expression for each algebraic expression. Now what we're going to do, we're going to go the opposite direction. By the way, at this point we have achieved, or hopefully achieved, part A of this. Be able to write from an algebraic expression into a verbal expression. Now we're going to work on part B of this lesson. Write an algebraic expression from the verbal expression. So we have 7 less than the product of 4 and the 5th power of b. Okay, so less than. Less than is a subtraction. Key words. It's a subtraction. We have product. Product is a multiplication. And we have power. Power is a letter raised to some sort of exponent. Okay, so we know that we're going to have 7 less than something else. Be careful on the order of this. 7 less than something else means that we are going to go subtract 7 onto whatever it is. So if we had 9, 7 less than that would be 9 minus 7, not 7 minus 9. So be careful about order. Product. Product of 4 and 5th power of b. Product means multiplication, so we are going to a multiplication of 4 and b raised to the 5th power. That is the verbal expression written algebraically. So make sure that you guys are able to follow along with that. Part B, the quotient of C plus 5 and the difference of 27 times D and 1. Okay, quotient is division. So break it apart. Pick the things that you want to, that you know. We know quotient's division, we know plus is addition, we know difference is subtraction, and we know times is multiplication. Now we have to figure out how it's going to be written. Quotient of two things. So we're going to put this as a fraction. The C plus 5 is before the and. So that means that we are going to have C plus 5 on top. And the difference of 27 times D and 1. Difference is subtraction. We have 27 times D, so let's put that on bottom, 27 times D. And we are doing the difference of this and this other number. So we go 27D minus by 1. That is the answer to that expression, written as a algebraic expression instead of a verbal expression. Part C, 3/5. 3/5 is a fraction. So let's go ahead and write that out. 3/5 of f added to 9 times the sum of 2 divided 2g and 5. Okay, so we know added means addition. We know times means multiplication. We know sum is addition. We know divided is a division. So we have 3/5. Let's go ahead and write this out. 3/5 of x. By the way, this word of is another word for multiplication. So we are going to times 3/5 to f. Then we are going to add this with 9 times something else. Well, 9 times what? 9 times the sum of something else. So we're going to go parentheses. 9 times the sum of 2 divided by g and 5. Okay, so we have the sum of 2 being divided by g and 5. So sum of 2 divided, basically we are finding the sum of 2, and then we are going to have a division of g and 5. So add g and 5. And we need to close that parenthesis. So this is the answer to that problem there. Remember, 3/5 of means multiply, so we multiply that to f, added to 9 times, so 9 times something, the sum of something, so 9 times the sum, so we're adding two things, of 2 divided to g and 5. Actually, this is 2 divided by g. The 5 should be added on after. So be careful of the wording. So it's actually 2 divided to g, or divided by g. That should actually be by. Then the and tells us that this is the other part to the addition. So that's why it would be plus 5 instead of saying divided by this and this. So 2 divided by g, divided to g would be 2 over g. And then we have to remember the sum, which is why it's plus the and is going to have with the 5. So that is writing that as an expression. Let's look at a few word problems. Application, right? We want application. The length of a rectangle is L. It's L units. And its width is 3 units less than the length. Less than was subtraction. Right? An algebraic expression for the perimeter of a rectangle. We need to remember what perimeter of a rectangle is. If we have a rectangle, let's go ahead and draw ourselves a rectangle. We have the length. We have the length. We have the width. We have the width. Perimeter is just adding everything up. So remember, perimeter of a rectangle is 2 of the length plus 2 of the width. That's perimeter. It's adding up all the sides, going around it as if we're walking around the object. So if we're wanting to write an algebraic expression for a perimeter, we don't need the equals and the p because we are not finding an equation, we're finding an expression. We are told that the length is L units and the width is 3 units less than the length. 3 units less than the length. So we know that the length, the width is going to be 3 units less than the length. So we are going to go length minus by 3 because whatever the length is, we are going to subtract 3 to end up with the width. 3 units less than the length. So in other words, our expression is going to be 2L, 2 times the length, plus 2 times the length less than, or the length minus by 3, because it's 3 less than the other value. So that is the expression we are looking for. Remember, length 2 times L plus 2 times W is length and width, and finding the perimeter. If the length is 3 units less than the length, if the width is 3 units less than the length, then that means W is L minus 3. So then it's just a substitution, putting it in there. Last thing we're doing. Oh, someone put my name in here. Mr. Stowell ordered 5 large pizzas and 2 small pizzas for a class party. Write an algebraic expression that represents the total cost of the pizza. Okay, well, they don't give us any price in here. Let's say that we have the L will be for large pizzas and the S will be for small pizzas, for the prices of those. So if we have 5 times the price for the large and 2 times the price for the small, and add those two prices together, isn't that going to be the total price? So that would be your expression for that one. That's actually probably one of the easiest expressions that we can have.